Hands-on Machine Learning with the Scikit-Learn 3rd edition is required textbook for this course. We will have a weekly reading assignments from this book as well. In order to be successful in this course, there are a few prerequisites that will be extremely helpful. First and foremost, it's important to have programming experience, particularly with Python. We will be utilizing many machine learning libraries that are available in Python. While we will be focusing on the machine learning aspects, it's important to have a solid understanding of Python programming so you don't get held back. Secondly, a basic understanding of math concepts, particularly linear algebra and matrices. The last one, some familiarity with the statistic, is also important. In addition to that, you should have a strong sense of curiosity, and you should be really excited about solving interesting problems and getting your hands on fascinating data. In machine learning, we learn by analyzing examples. And one of the critical questions we ask is, what can you say about the new point you've never seen before? To help illustrate this concept, I will present you with some multiple choice example. I recommend pausing the video to consider your answer before unpausing to see the correct answer. Let's start with a scatter plot. Suppose this is your data. It comes in two categories in 2 dimensions. And now we get a new data point and comes over here. I put question mark. So again, one of the fundamental questions in machine learning is what you can say about a new data point you have never seen before. Given this past data here and this, could you tell me, is this data point, the new data point, is more like to red circle or green circle? I will make it multiple choice. So I have A, more like green. B is more like red. So what I want you to do, I would like you to pause the video and you decide which one. All right, so I can tell you are correct, and the answer will be this point, this data point is more like to red data. Now let's make it a little bit complicated. What about if we have a point right over here? So another question is, this given point, is that close to green? Not close, is that more like green or more like red? I'm going to add part C as well. And C, I'm going to say unclear. So pause and then give me the answer. All right, I'm going to say this is unclear. It's not like green. We cannot say is to this group or to the red. It's almost, I made the question to be exactly middle of these two group. So we're going to go with unclear for now. All right, great work. So now what I'm going to do, I'm going to bring a machine and I'm going to ask the same question. So the question was this point. Is it more like red or more like green? So what machine learning algorithms do is defining a decision surface. Something like this separates two classes. One side, they will be predicted red circle for every possible data point, whereas the other side, they predict the opposite concepts. So for this data point, so definitely it will be on the red region. So the answer will be more like red. When the decision surface is a straight line, so instead of this curve, you have a straight line, we call it linear. All right, I'm gonna keep this this robot here as a machine. I'm also gonna add this person here. So what I'm gonna do, I'm gonna draw 3 decision surface which are linear. So one of them I'm gonna make it, select its color. This is first one, and I make another one something like this, and one more like this. Let me add one more here. It might get confusing, but so we have 4 decision surface and they're linear. I'm gonna call them A, B, C, and D. And I will like to write the word which is decision surface linear. So we will get back to this keyword later, but for now we know the machine makes it create a decision surface, and we are dealing with the line, so they call it linear, and we also should be able to find the best one. So please pause the video and tell me or select which line you think will best generalize the new data. So this was a tricky question. I would select this surface, which is B. If you look at A, this surface here, so definitely will not be a good choice because it misclassify our existing data, because in this side of the region we have green, we also have red, so this is not a good idea. D and C also misclassified, but we're only dealing with one point here and one point there. So for line C or region C, we only misclassify one, and same for line D. So we will get to this. This might be outlier, but for this example, B was the best one. Let's talk about something related to decision surface, an algorithm called SVM. S is support vector machine. So we will work on this later, but for now I'm just want to make a couple quizzes or a couple questions. So a little bit about SVM. So support vector machine is an algorithm that takes this data, so as an input, and outputs a line that separates these classes. So we have two classes here, red and green. So if when we're using support vector machine, it gives us a line that separates them. So let's have it in 3 lines. I'm going to make 3 different lines, and your job is to tell me which one is the answer. One of them I'm going to go like this. Let me change the color to blue. So this first one. Then we have one more here. And another one there. So your job is to tell me which one, A, B, or C, you think this separates the data correctly. I can pause and unpause. So the correct answer will be A, which separate them to 2 different classes. Let me make it a little bit tricky. So I'm going to get rid of this. I'm going to modify the data. I'm going to delete this guy and delete that. So same question, I'm making 3 lines, and your job is to select the best one that separate them. So I'm going to make this one over here. One over here. And one in the middle. I'm going to call this A, B, C. You're going to pause the video. So your job is to check the line that you think best separate the data. All right. Obviously, all 3 of them seems to separate the data, but one of them is the best. We're going to go with the B, so B is the best. What this line does, the other one don't, it maximizes the distance to the nearest point, and it does this relatively to both classes. So the distance here to this point and to that point, to this point, to that point. So, and there is a name for that. So it's the line that maximizes the distance to the nearest point in either classes. The distance is often called margin. So this distance, we're going to get to that later in this course, but I'm going to call it margin. I modify the data to make it more tricky, and I give you 2 lines. One of them is A, another one is B. So the question is, which of 2 lines do you think maximize the margin and would be correct result of a support vector machine? You can pause the video, and we are talking about SVM algorithms. So the correct answer will be B, and because line A, it will have a classification error because the red is in this side, the other side of all the red. So support vector machine puts first and the foremost the correct classification of the labels and then maximize the margin.